Now we're going to see that what is the variation of the shape function throughout a one-dimensional quadratic element. So before going to see that one, let us recalling that the shape function formulas n1 would be equal to the, that is called shape function n1 is equal to the zeta into zeta minus 1 by 2. Similarly, the shape function n2 is equal to the zeta into zeta plus 1 by 2. The n3 is equal to the 1 minus zeta square. So this we have derived in the last video. So here the displacement function can be say that u is equal to n1 q1 plus n2 q2 plus n3 q3. So now I would like to draw the what is the variation of the shape function. Let us draw that the variation of the n1. So let us first draw the shape function n1 variation. I can I would like to take that the same element that is called quad element having a nodal point 1 as well as nodal point 2. At the middle it is a nodal point 3. So I know that one at nodal point 1 the value of the zeta that is equal to zeta is equal to the minus 1. At nodal point 3 the zeta is equal to the 0. At nodal point 2 the zeta is equal to the plus 1. Okay, so in a n1, if I put down that the zeta is equal to minus 1, so therefore, if you put down that the zeta is equal to the minus 1 at node 1, the n1 can be write as it is equal to the minus 1 into minus 1 divided by the 2. Minus 1 and here it becomes that minus 2. Minus 2 into again the minus 1 will become that 2. 2 by 2 you're going to get that 1. So here you're going to get the magnitude would be equal to the 1. Let us say here the magnitude would be the, let us say the height would be from here to here. Let us say this would be the unit magnitude 1. Okay, so this would be, let us say, the unit magnitude 1. So if you put down that zeta is equal to minus 1, at node point 1, the n1 value is equal to the unit 1. Similarly, the n1 value at node 3, at node 3. So at node 3, the zeta becomes that it is equal to the 0. So if you put down that 0 in the n1 formula, therefore n1 becomes that as 0 into 0 minus 1 by 2. So this will give the value of 0. So means that the shape function n1 will become that 0 at this point of time. So join this with a smooth curve. So let us draw in the this with a smooth curve because the curve follow that it is a quadratic equation. So therefore it should not be a linear curve, it should be a smooth curve. Okay, let us join these two. Now let us try to find out what is the n1 value at node 2. So at node 2 the zeta becomes that plus 1. So zeta becomes plus 1, therefore n1 value at the node point 2 it is equal to 1. Again zeta is equal to 1 into 1 minus 1 divided by the 2. 1 minus 1 will become that 0 and this would be become that 0. Okay, so the n1 value at node number 2 again it is 0. So therefore it is a quadratic curve. So therefore it goes down as well as it comes up because from here to here it follow the downward shape. So therefore then after that it is again joined here. So therefore the n1 at nodal point 1 must be equal to 1. The n1 at nodal number 3 is 0. The n1 at nodal number 2 would be equal to 0. So this is a variation of the shape function for a element. Similarly, let us try to draw the variation of the shape function n2 on a quad element. So let us take that the quad element having the nodal point 1 and nodal point 2. The middle would be the, let us say, nodal point 3. So at nodal point 3, I know that one the zeta is equal to the 0. At nodal point 2, zeta is become that plus 1. At nodal point 1, it becomes that is equal to the minus 1. So let us try to substitute this one in a n2 formula. So this is the now I would like to draw the what is the variation of the shape function n2. So I would like to take this shape function into formula, that is zeta into zeta plus 1 by 2. So if zeta is equal plus 1, so this become that 1 plus 1 become that 2 into 1 again 2, and at 0.1, sorry, okay, again the zeta becomes that it is a minus 1. At node 1 it will become minus 1, so therefore here minus 1 and the zeta is equal again minus 1 plus 1. So minus 1 plus 1 become the 0, 0 into something 0. So therefore the shape function values at node zero point 0.1, that is called n2 would be equal to 0, means that it start here. Okay, so now let us try to see that what is the value of the uh, n2 at zeta is equal to 0. So if zeta is equal to 0, again it has become that 0. Okay, so therefore the n2 values at this point also it will become 0. Let us try to find out what would be the value of the n2 at node number 2. So at node number 2 the value is equal to plus 1. If you put down the plus 1 in your n2 function, 1, 1 plus 1 become that 2, 2 into 1, 2, 2 by 2 become that it is equal to 1. So therefore the value become that 1. So it is a positive 1, so therefore it goes up at this point. So from here to here it is the magnitude of 1. Okay, this is a magnitude of 1. So this would be the variation, and let us join the third point with a second point, a smooth curve, and here this will be moves like this. Why it is goes to downward? Because here it starts from 0, again it reaches to the 0, and it must goes to the 1, means that the curve nature would be there like this only. So this would be the variation of the n2 throughout the quadratic element. So now let us try to see that what is the variation of the n3 in a quadratic element. So the n3 formula, we know that one, it is equal to the n3 is equal to the 1 minus zeta square. So this would be the formula. So I would like to draw the variation of the n3. So now I would like to try to draw the what is the variation of the n3 at zero point 0.1 and at zero point 0.2, and middle is equal to at zero point 0.3. So I know that one at zero point 0.1 the zeta is equal to the minus 1. At zero point 0.2 zeta is equal to plus 1. At zero point 0.3 zeta is equal to the 0. So let us try to solve that at zeta is equal to the minus 1. Means that at node 1 the n3 value becomes that is equal to zeta is equal, you have put on minus 1. So n3 at node 1 will become that if zeta is equal to minus 1, 1 minus of zeta is equal to minus 1 whole square. So this is the thing. Minus 1 whole square become the plus 1 plus 1, that is equal minus of plus 1, again it is equal 1 minus 1, it becomes that is 0. So means that the variation of the shape function value at the node point 1, it is become that the n3 is equal to the 0 at node point 1. Similarly, let us try to find out the what is the value of n3 at node point 2. So at node 2, at node 2, let us try to find out that what is the value of the n3 function. Okay, so at node 2 that is equal zeta is equal to the plus 1. If you put down here, therefore n3 would be equal to the 1 minus of plus 1. This is called zeta is equal to plus 1. So if you put down that plus 1 whole square, therefore this becomes that it is equal to the again 0. So n3 value at the node point 1, node point 2 also it is equal to 0. Now let us try to find out that at node 3 the value of the n3 would be. So at node 3 the zeta becomes that it is equal to 0. So if zeta is equal to 0, so therefore 1 minus 0 square, this will become that again it is equal to 1. So it is positive 1. So means that at node point 3 the n3 would become that 1. So let us draw that the 1 magnitude. Let us say this would be the straight line only. Okay, this is a magnitude 1. So at this point it would be there. So therefore you have to join the 0 to the highest magnitude point 1 with a smooth curve, and from there to the again the shape function value is going to decrease. So this is a variation of the shape function in a quadratic element. So this question is very important. You may be going to get the question based on the variation of the shape function for a quadratic element. Thank you.